Okay, so this is a little bit of lesson 73 that we didn't get to. I just want to make sure that everybody understands about a difference of squares. Remember we talked about a difference of squares is when you are subtracting one square minus another square, perfect squares. And when you do that, you get a product of conjugates. And I want to make sure everybody understands how to do that. So if you look at negative 36x to the 6th, y to the 4th, plus 49a squared, it's not a difference right now, it's addition. You want that sign in the middle to be minus. So you need to rearrange these so that it is going to be 49a squared minus 36x to the 6th, y to the 4th. All right, and now you want to write this as something squared minus something squared. All right. So you look at 49a squared, you know that 49 is 7 squared, and a squared is a squared. So 49a squared is 7a quantity squared. If you multiply 7a times 7a, you get 49a squared. So we've written that as a square, something squared. 36x to the 6th, y to the 4th can also be written as something squared. 36 is 6 squared. X to the 6th is x cubed squared. Because remember, when you raise a power to another power, you multiply the exponents. And then y to the 4th is y squared squared. All right, so if you want to write that term as a perfect square, you're going to write it as 6x cubed y squared squared. All right, so now you have your a and you have your b, right? A squared minus b squared is equal to a plus b times a minus b. So you've got your a, your first thing, and you've got your b, your second thing. All right, so it's going to be first thing plus second thing times first thing minus second thing. So here I already wrote that first part. 7a plus 6x cubed y squared, and then 7a minus 6x cubed y squared. So you've written that difference of squares as a product of conjugates. Remember, conjugates look just the same except for their middle sign is opposite. So that's how you factor a difference of squares. And be definitely sure that you know how to do that, because that's super important and you're going to be using it over and over again. So factoring a difference of squares, very important. All right, now probability without replacement. We've already talked about probability with replacement. That is when your events don't really affect each other. When you are trying to figure out the probability of a certain sequence of events, and each event doesn't affect the other. Okay, that's what we are talking about when we talk about with replacement. So for example, when determining the probability of multiple events, it may be necessary to consider how one event may affect the following events. That's what I just said. For example, an urn contains 3 black marbles and 5 white marbles. A marble is drawn at random and replaced, and then a second marble is drawn. So what is the probability that both marbles are black? All right, so in the first instance, when it says an urn contains 3, it says a marble is drawn at random and replaced. Okay, and then you're going to draw a second marble. Well, that first event, the one where you drew a marble and put it back, that didn't affect the second event because you put the marble back. It looks exactly the way it did in the beginning. So these two events, pulling a marble and then pulling another marble, they're not going to affect each other because you put the marble back in the urn. All right. So in that case, the probability that both marbles are black is just the product of first one, probability that the first one is black, which is 3 over 8, because you've got 8 marbles and 3 are black. So that's the probability that the first marble will be black. The probability that the second marble will be black is the same as the first one, because you put the marble back in there. There's 3 black marbles, 8 marbles total, so the probability of pulling out a black is 3/8. So the probability of pulling out 2 blacks in a row with replacement, meaning you put the first marble back in, is going to be 9/64. All right, so those two events don't affect each other at all. So the probability of pulling one black and another black is just the product of pulling a black. All right, now, what if you don't put the marble back in? All right, so if the first marble is not replaced, oops, if you take that marble out and you don't put it back in, then the probability, it says what is the probability that both marbles would be black in that case? Well, in that case, you pulled a marble out, the probability was 3/8 that it would be black. There's 3 blacks, total of 8 marbles. All right, but this time you don't put it back in, you leave it out. All right, so the probability on the second draw is different because that first event affects the second event. All right, so now when you pull that second marble out, there's only 2 blacks in there. So and there's only 7 total marbles in there. So the probability of pulling a black on the second draw is only 2/7. 7 total marbles, only 2 of them are black. And so the probability of pulling a black and another black is that product, 6/56, or you can reduce that to 3/28. So when we do a probability problem like this without replacement, it means we are not putting the marble back in, which is going to affect the next event. All right, so example 2, an urn contains 4 red marbles and 7 blue marbles. 2 marbles are drawn at random. What is the probability that the first is red and the second is blue if the marbles are drawn with replacement? Right? With replacement means you're going to put the marbles back in after you draw them out. All right, and you're looking for the probability that the first is red and the second is blue. So in part A, you pull out a marble and we're trying to see the probability that the first is red. So you pull the probability that the first marble is going to be red is 4/11. There are 11 marbles, 4 of them are red. And so you pull that marble out and you put it back in. All right, and now the probability that the second marble is blue is going to be 7/11 because there are 11 marbles in the jar and 7 of them are blue. And so that probability is the product of the 2 events. That you drew a red first time, blue second time, multiply it. Yeah, you drew a blue, put it back in. All right, and so that's going to be 28/121. Now, part B says without replacement. All right, so if you're going to do this without replacement, that means you're not going to put that first red marble back in the jar. So the probability of pulling a red on the first draw is still 4/11, but you pull it out and you don't put it back in. So the probability of drawing a blue on the second draw is now not 7/11, it's 7/10 because there's only 10 marbles left in the jar. So there's still 7 blues, but there are only 10 total. So 7/10. So the final probability there is 28/110, which is 14/55. So with replacement means you put the marbles back in after you draw them out. Without replacement means you don't put the marbles back in, which means you have changed the situation on your second draw or your third draw or whatever. All right, so that's the end of lesson 73. We didn't finish the whole thing in class, so that's the end of that. Don't forget, it's super important that you understand how to factor a difference of squares. Really important. All right, so